Good morning. This is your pre-algebra lesson for Tuesday, April the 14th, I believe is today's date. And today we're going to continue looking at lesson 82. We're not really going to do lesson 82 again today. What we are going to do is we're going to spend some time reviewing, then we're going to review that lesson because there's a couple of areas where a couple of you have mentioned you were a little still uncertain. And with your finals not being that far away, I want to make sure that you are completely prepared for this, okay? So let's do a little review. We have 5 times 10 to the negative 15th power times 1 times 10 to the 8th power. Now we're multiplying these two scientific notations. Remember, scientific notation is going to be when our first number is going to be between 1 and 10. We're multiplying it by a power of 10. When this number, this exponent, is positive, that means our number is very large. If our exponent is negative, that means our standard number, if we write it in standard form, is very, very small. It's going to be 0.000, whatever. Okay? It's very simple. Multiply the first two numbers. The 5 and the 1 are multiplied. So 1 times 5 is 5. Of course, you're going to keep the times 10. The question is, what's the power? All you're going to do is add the powers. You have a negative 15 plus a positive 8, so your answer is negative 7. And I hope that makes really clear sense to you. Let's look at the next one. We have 1 times 10 to the negative 27th power times 4 times 10 to the negative 20th power. So again, multiply the first two numbers, your 1 and your 4, and you get 1 times 4 is 4. Keep your times 10. Now, what power is that? You have a negative 27. Remember, we add the powers when we multiply. So we have negative 27 plus a negative 20. So our answer is negative 47. So our answer is 4 times 10 to the negative 47th power. Okay? If you still have a question about how to multiply scientific notations, either drop me a note in the comments column or send me a text or call me, okay? But let me know that you have a problem. This is way, way, way back at the beginning of the year, but because I know it's going to be on your final exam, because I know it's going to be on your chapter test, I want us to keep it fresh in our minds, okay? I have the numbers 12, 18, and 27. I need to find the least common multiple. I need to do that by writing them in their prime numbers. So first I need to find the prime factorization of each number. If you remember, with prime factorizations, we're going to do the division of primes. So we're going to put an upside down division mark. Always use the smallest prime number possible. So the first thing we ask ourselves, is the number even? Yes, it is. So the smallest prime number that'll go into an even number is the number 2. Okay, so we have 2. 2 goes into 12 6 times. Since 6 is still even, we again divide by 2. This time we have 3. What do we know about 3? 3 is prime. So our prime factorization is for 12 is 2 times 2 times 3. Now for the number 18, again it is even. So start with the number 2. That gives us 9. 9 is not prime, but it's not even, so we cannot use 2 again. So we go to the next prime number, which is 3. Will 3 go into 9? Yes, it will. It goes into it 3 times. Now it is prime. Look at our 27. 27 cannot be divided by 2 because it's not even. Can you divide 27 by 3? Yes, you can. 27 divided by 3 is 9. And again, we're going to use our 9s. So our prime factorization for 12 is 2 times 2 times 3. The prime factorization for 18 is 2 times 3 times 3. And our prime factorization for 27 is 3 times 3 times 3. How do I find my least common multiple? I must use every single term, the different terms, in my least common multiple. In other words, if I have a 2 somewhere in this mess, there must be a 2 in my answer. If there's a 3, there must be a 3. If there's a 5 up here, there must be a 5. Okay? So I find the different factors. Then I ask myself, which number, 12, 18, or 27, has the most of those factors? So the first factor is 2. There are 2 2's in 12. There's 1 2 in 18 and 0 2's in 27. So who had the most 2's? The number 12. Since 12 has 2, I write 2 down here. For some of you, I remember, you're like, oh, I remember this. But just in case someone doesn't, I want to go over it. The next factor we have is 3. We have 1 3, 2 3's, or 3 3's. Which one is the most? Well, the one that has the 3. So we're going to say 3 times 3 times 3. Now, I can multiply these any way I want, okay? But probably the easiest way is to go 3 times 3 times 3. Oh, I already know that. That's 27. Then 27 times 2. And then that times 2. Find out your answer real quickly in your paper. Hopefully, when you did this, you found the least common multiple to be what? Hopefully, you found it to be 108. Okay? You should have got 108. If you have a problem with scientific notation, or if you need me to review least common multiples with you, let me know. I can have a conference call with you if that makes it easier. Let's look at the bottom. We have powers here. We have all kinds of things. We have brackets, we have roots, we have exponents, we have parentheses. What do we do first? In our orders of operation, you have to do the powers and parentheses first. You can do powers and square roots, but when it comes to solving things and combining, you must start with the innermost parentheses. So let's go over here. We do have a power, 2 to the 3rd power. That means 2 times 2 is 4. 4 times 2 is 8. So I can write 8 right there. I can't combine it with anything yet, but I can get rid of the power. Okay, what is the square root of 36? It is 6. I can write that down. Now bring down my bracket, and I say 3 squared, or 3 times 3 is 9. Parentheses, 3 squared again is 9. Bring down my subtraction sign. 2 cubed. 2 times 2 is 4. 4 times 2 is 8. Parentheses, another set of parentheses. Now I have 4 squared, or 4 times 4 is 16. Minus 4 to the 4th power. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Now we have plus 3 and a bracket. Now, I've gotten rid of all of my powers. I got rid of all of my exponents, but I haven't combined anything yet. All I've done is got rid of powers and parentheses. I'm sorry, powers and square roots. Now, I can start getting rid of the parentheses, but what do I do first? Go to the innermost parentheses first. In other words, I can do nothing with the 8, the 6, or the bracket. I have a parentheses here. 9 minus 1 is, 9 minus 8 is 1. Then I have another set of parentheses. 16 minus 16 is 0. You cannot skip that. You can't say, okay, that's nothing, so I'll just move on. No, you have to put the 0 down. Then you have a plus 3. Whoops. Hope you can see that okay down there. Now we have 8 plus 6 brackets, 9 times 1 times 0 plus 3. Okay, so let's solve that. Innermost brackets, okay, so we have 9 times 1 is 9, times 0 is 0. That's why it was important that we brought it down. Plus 3 is 3. Okay, still have a bracket, but now we have 8 plus 6, bracket 3. So 6 plus 3 is 18, and I'm going to write that over here. 18 plus 8 is 26. Now, if you had not brought that 0 down, instead of saying 9 times 1 times 0 plus 3, you would have, and in which case you got 3. If you would not have brought that 0 down, you would have said 9 times 1 is 9 plus 3 is 12. Would have totally changed your answer. So you have to bring everything down. Let's look at the next thing we're going to talk about today. Excuse me. We have this diagram up here, and you know that I'm not the greatest artist. There's a reason Ms. Argueta teaches geometry and not Mrs. Turner, okay? But we're going to find the volume. If you don't like my picture, you may look in your book. We're going to look at this picture actually came from lesson 81, number 12. And it says, find the volume of the right solid whose base is the figure shown on the left and whose sides are 2 yards high. okay? So the first thing we want to do is find volume. How do you find volume? Volume is the total area times the height. Now, when I look at this, I don't know an easy way to do this as one figure. I have to break it into two. Where am I going to break it? Hopefully you said right here. Because now I have a what? I have a rectangle and a triangle. So now instead of leaving it like this, I'm going to say my area is the area of my rectangle plus the area of my triangle. Then, after I add those, I'll multiply it by my height. Okay? How do I find the area of a rectangle? Volume equals length times width. How do I find the area of the triangle? Base times height divided by 2. And again, so far, you say, Mrs. Turner, do I have to write all those down? Yes, 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 yes. Why? Because this is showing your logic progression, your very logical progression before you start putting your numbers in. This is going to help you look at things logically, especially when you get into geometry and Miss Argueta starts saying, prove that. How did you get that? And what proof? What do you know? What fact tells you that? What postulate tells you that? This is going to help you learn how to think logically, break it apart, and look at it segment by segment. Okay? Now, what is the length and the width of my rectangle? Well, my volume equals, as I said, length times width. This whole thing is 30, but the top of it's only 10. So my rectangle is 10 by 20. Okay? Then I have my triangle. The base of my triangle is not this whole thing. It's only from the dotted line over. And of course, mine isn't drawn to scale. Okay? But I know that this is 10, so to this dotted line is 10. So 30 minus 10 makes this 20. Okay, so my base is 20, and my height is 20, and I'm going to divide it by 2. Now, once I've done that, I'm going to multiply by the height. Go back to your story problem, and let's look and see what the height is. It tells us that the height is 2 yards high. Now, we know all of our other dimensions are in feet. So to make this the easiest way, we're going to say, okay, it is 2 yards. So how many feet are in a yard? 3. So we're going to multiply this by 3, but we're also going to multiply that by 2. Why? Because if there's 3 feet in a yard and mine is 2 yards, then I'm going to say 2 times 3, okay? Now, let's solve this, okay? So we're going to say 10 times 20 is 200, got our little brackets, plus 20 times 20 divided by 2 is going to be 400, okay? This is going to all be 400, I say. So if we have 20 times 20, all right, divided by 2, all right, I'm going to get 200, and then we're going to say times 6. So now we have the volume is 400 times 6. Volume equals 2,400. Okay? We're going to have 2,400. But what I forgot to say was about the units. Everything inside this is area. So that's square. I should write that in here. Sorry about that. Is square feet. Okay? So if this is square and this is just feet, our ends are going to be, the end of it is going to be cubic feet. Sorry about that. I should have put that on there. Okay? The next one is surface area. And for some reason, we're still having trouble with this. So let's talk about it before we solve it. All right. What is the basic shape of our diagram here? It's a what? It's called the surface area of a right prism. Okay? A right prism simply means it's shaped like a triangle, but it's going to have length. If you remember in class, I brought in a little prism about this big, and I showed you it, and we could use it to reflect and bend light, okay, in science, okay? So if this was an actual prism that I had here today, we would have the two ends that would both be shaped like a what? A triangle. The two sides are going to be shaped like a rectangle, plus we have the bottom. So in the surface area of a right prism, how many sides do you have? You have 5, okay? Now, I want you to take a moment. I want you to write down how you think we're going to solve the surface area. Write it down before you start part 2 of our lesson today.